everyone, welcome back to Damks Analytics YouTube channel. My name is Tumike Adebayo and I'll be able to take us through today's video. So here's a new series on R programming language for beginners, emphasis on beginners, which means you don't need any background knowledge for you to participate in this class. So if you've always wanted to learn a programming language or start a career as a data analyst, here's the opportunity you'll be waiting for. So ensure you sit back, subscribe to our channel and turn on your notification bell so you can be notified whenever we post a new video. Thank you. So a brief introduction on R. R has become one of the most widely used programming language for statistical computing and data analysis. It offers a wide variety of statistics-related libraries and packages, and this provides a favorable environment for statistical computing and designs. So before we commence the class, let me introduce you to R Studio overview. So once you download your R Studio and you launch it, this is the interface. This is what you see. And as you can see, we have 4 different windows. So I'm going to go ahead to explain to you what each of this panel means. So the first one here, this is what this panel is called source and script panel. So this is where you write your codes, and your codes here will not be evaluated until you run it. So, and this is where we spend most of our time working. Then the second part here is called the console panel. This console panel is where you write the code from the source is evaluated by R. Then you can also use this console to perform quick calculations that you don't want to save. But if you want to save your code and document it, I will encourage you to use the source panel. Then the third panel here, this is where we have the list of data, which is the environment panel. So this is where the list of data you have imported or created can be found. So you get to understand that better as we go ahead in the video. Then this last panel, this panel is called the file and plot panels. As you can see, we have files, plots, packages, help, viewers, presentation. So in this panel, you have your files directories, view your plots, then you see your packages and access R help. For example, when you have a package and you want to know what the package entails, you use the command question mark and the function name. Then once you click that, you're going to see the details here at the files and plots panels. So this is just a brief introduction. So let's go ahead to today's class. Okay, so from here you can see already that our topic today is basic building blocks in R. So the objective of this class include how to assign values to variable names, rules to naming a variable in R. We'll learn about vectors. We'll learn on how to combine vectors. We'll learn how to create new vectors from existing vectors. We'll learn about vector arithmetic and the concept of recycling in R. For the purpose of this class, we're going to be using R Notebook, and that's because it has the ability for us to run our chunk separately. What do I mean by chunk? This is how to create chunk. Click on R, and so you write our code inside this chunk and we'll be able to run it separately. So you see this often as we go ahead in the video, so you'll not be confused on what it means. So let me just delete that. And because we'll be using our source panel basically, so let me just I want to collapse this. Yeah, okay, just a bit. Okay, so we say here that R can be used as an interactive calculator. So what do we mean? Let's say we have this 5 plus 7, and so once we run this chunk, it gives us a result to be 12. And of course, we can also see this in our console panel here. So, but R is more than that, of course. So let's say that we can as well create a new variable that stores the results, so that we don't have to retype the expression anytime we need the results. So the way to assign a value to a variable in R is by using the assignment operator. So, and the assignment operator is this. Yes, can be represented as this. So you are assigning the value on the right side of the arrow to the variable name on the left side of the arrow. So this is the variable name x, and this is the value 5 plus 7. So we are assigning this value of 5 plus 7 to this variable name x. So let me try. Let's run it. So as you can see, there is no result. Yes, I noticed it. So let's see in console. Yeah, it just brings back the expression x equals to 5 plus 7. So there's no result, and that's because R assumes that you don't want to see the results immediately until you print the variable name. So let's now print the variable name. Let's say print x, and say let's run that again. Okay, now you can see it prints the value to be 12. So let's try creating another variable y that stores the value x minus 3. So I opened a new chunk and we have a variable name y, which is assigned to the value x minus 3. Don't forget we have our x to be 12, right? So let's print y and see what our result is. Okay, so we have 9. So basically it's the 12 minus 3, which is equals to 9. So that is how to create a variable name. So there are rules to naming variables in R. We're going to talk about 5 of them. And the first one here is the name can be combination of letters, digits, underscore, and dot. So the first example here just combines letter, number, underscore, and letter. So we have this to be equals to 12. So let's try and print this if it work. Just to explain that name can be, the variable name can be combination of letters, digits, underscore. So when we run this, yeah, it gives us the value to be 12. So then there's another example here combining letter, number, letter, and dot. So if we run this, let's run this and see our result. So yes, it gave us to be 34. So this is justifying the first rules to naming variables, that it can be combinations of letters, digits, underscore, and dot. So let's go to another condition. This one says it must start with a letter or dot, but if it starts with dot, the second character cannot be numbered. So this is an example here. We started here with a dot and a character. So let's see. Mind you, I'm using this hashtag, so that's the comment. I want to just comment this out so it won't print it for me yet. So that's what I'm doing. And okay, so the first one here, dot and k, that is dot and the letter. So let's run it and see if it works. Of course, okay, yeah, it's giving me error for this. Okay, so let's run that again. So as you can see, it gave us the answer to be 17, which means it's correct. So let's go for the other one. It says that if you are starting with a dot, so which means the second character cannot be a number. So we created another variable name and use a number after the dot. So let's see. I'm sure we're going to have a problem there. So let me comment this out. I don't want it to print it for me again. Okay, so let's print this. So as you can see, unexpected symbol in the 7D, and that's because of this number. So let's erase the 7 and print it again. So we are fine. And that's the second condition. I hope we understand. So let's go to the third condition. It says variable names are case sensitive. What does that mean? Take for example, we have a variable name height. Mind you, we have h to be a lowercase, which is equals to 34.8. Now we want to print height, but this time we use a uppercase h. So let's print that and see. It says object height not found. So when we want to debug this, let's change this to uppercase h for height and say and print that again. So we are good 34.8. So this is what it means when it says that variable names are case sensitive. So you have to be sure if you are using lowercase or uppercase in naming your variables. So the third condition here says it cannot start with a number or an underscore. So the example explains that the first one here started with a number. So we have 25y equals 25. So when we run that, of course, we have a problem. Unexpected symbol in 25. So, but let's say we erase, of course, we erase the, or let's say we put another value, maybe a letter in front. And let's run again. Yeah, of course, once we print that, E25y. It's going to give us our value 25. Then the second one here, the second example here is underscore. Remember, we cannot start with underscore, so we started with underscore as a variable name here. So let's see, is it possible to run that? No. So till we erase the underscore and we run again, we have our value once we print big EIG. Yeah, so 69. So the fifth condition here says, apart from dot and underscore, no other special character is allowed. So there's an example including all like 3 different special character just to explain that. So let's comment this out again because I don't want to print that here. So when we run it, it's giving us unexpected assignments in AB and this special character. So till we clear that off and try to run again, of course we have to print it before we can get the value AB. So when we run it, we are good to go. Then doing the same thing here, AB $sign, that's another special character which I do not recognize as a variable name. So we have a problem, unexpected assignments in AB underscore. So once we clear that off, we are going to have the correct answer, or I can just put a number here. Let me put a number. Yes, so we have 11, right? So then the last one here also use another special character. Then when we print that, of course, let's run it, we're going to have a problem too. So let's erase that and add another character. Okay, happy. So let's print happy. So yes, 30. So this explains that apart from dot and underscore, no other special character is allowed. So like I said, there are other conditions, but we just pick this 5 so you can check online if you really want to get more. But you shouldn't have a problem naming variables once you stick to using a character or combining character and number and underscore. We ensure that you don't start it with a number as explained. So let's go to another important part of this class, and that is vectors in R. So a vector in R is an ordered collection of values. It stores a sequence of elements of the same type, which can be numeric, integer, character, or logical. The easiest way to create a vector in R is to use this function, and this stands for either concatenate or combine. So let's say, for example, we create a vector called Z, and it has 3 elements: 2.5, 7, and 3.19. So when we print Z, we're going to have these 3 elements. So let's say, for example, we forget to add the combine function. So let's see what we'll have. You say R didn't see it as a vector, so that means we have to constantly ensure that when you want to create a vector, you have the function concatenate included. Okay, so let's say we want to check the length of a vector. We have to use it using this function length. So let's say we want to find the length of this vector Z. So once we print that, it's going to give us to be 3, which is 1, 2, and 3. So let's say we have 1.9. So let's see what our length will give us, which is 5. 1, 2, 3, 4, 5. So that's the length. Length is the number of elements in the vector. So let's say we want to know the class of a vector as well. We use this using this function class, and when we want to get the class of this vector Z, when we print it, it's going to give us to be numeric, so which is the class of this vector Z. So let's go to combining 2 vectors. Let's say we have vector A, which has 4 elements, 1, 3, 5, and 7. Then we have vector B, which has elements 9, 11, and 15. And we want to combine A and B. Then we want it to have, we created another vector D that has the two vectors A and B. So this is the function. Don't forget your concatenate function, then A comma B. So once we print D, it's going to give us all the elements in A and B, which is 1, 3, 5, 7, 9, 11, and 15. So what if you want it to start from the elements of B down to the elements of A? So that means you have to alternate this to be B comma A. So when we print our D, so it will start counting from B, elements of B, 9, 11, 15, then 1, 3, 5, and 7. So let's say we want to find the length of the vector D. It's going to give us 7, which is 1, 2, 3, 4, 5, 6, 7. So this is how to combine two vectors. You use your concatenate function, then you could separate each of the vectors by using this command sign. So let's go to how to create a new vector from an existing vectors. So we open a new chunk. Don't forget our vector Z, which has elements 2.5, 7, and 3.19. Then we want to create a new vector V, and this new vector V will have the elements of Z, all the elements of Z, then number 32, and all the elements of Z. So we can say, before we even print it, before we run this chunk, let's just try to get what the result will be like. So that means it will combine all these elements: 2.5, 7, 3.9, then 32, and again 2.5, 7, 3.9. So let's print it and see what we have exactly. So we have 2.5, 7, 3.9, then we have 32, which is there, then we have 2.507 and 3.9. Then if we want to get the length of this of V, it's going to give us 7. Okay, so this is how to create new vectors from an existing vectors. So we created a new vector V from an existing vector Z. So let's go to vector arithmetic. So we have some basic arithmetic operators in R, just like normal fundamental mathematics. We have addition, which is this plus. So when we run this, so we have x plus y, which is 10 plus 5, the addition. Then we have the subtraction, 10 minus 5, which is 5. Then we have multiplication, and this multiplication is using this and this multiplication is using this asterisk sign, which is x multiplied by y, we have 50. Then we have division, which is represented by this sign. We also have exponential, which is represented by this sign. So x exponential y is going to give us this value. Then we also have the modulus. Modulus means to return the remainder from division. So when we say 10 modulus of y, which is 10 divided by 5, is going to give us 0, because we are going to have the value 2, which is where this comes in integer division. So 10 divided by 5 is 2, which is this overall integer 2. Then we have the square root, which is square root of 25, which gives us 5. So this is the function name for square root, sqrt. So let's go ahead. Numeric vectors can also be used in arithmetic expressions. So what do I mean? Let's say, for example, we have a vector z that we'll be using, which is 2.57 and 3.19. Then we created another variable named array, and we want to perform this arithmetic expression of z, which is this vector multiplied by 2 plus 100. So how we multiply each of the elements in I will multiply each of these elements in Z by 2, then add 100. So what do I mean? Let's say, for example, I will take this first value 2.5. So it will take this 2.5. Let me get my calculator. Okay, so I will take this 2.5, it will multiply by 2, then add 100 plus 100. So we have 105. So that we have what the first value is going to be before we even run it. So let's run it and see what our answer is exactly. So we have 105. So the second element of z, which is 7, so r is going to take 7. It takes 7, multiply by 2, then add 100, which is equals to 114. So basically, it's for r to for a vector, for us to use a vector for arithmetic expression, r is going to take each of the elements in this vector and use the arithmetic operators for us to get it. So this is what we have for this. Then let's solve more examples. Let's say we find the square root of z minus 1. Then we assign a new variable name called s squared. So we created a new variable name s squared, and in this s squared we want the value to be the square root of z minus 1. Don't forget the function name for square root is sqrt, then into z minus 1. So basically what r will do is r will subtract 1 from each of the elements in z, then the square root respectively. So what do I mean? Let's say, for example, let me comment this out and print what our z is. So this is z, right? So let me get my calculator and try to do it manually before we print and see what our result looks like. So what I will do is the first value here is 2.50. 2.50. It will subtract 1 from that, minus 1, which is equals to 1.5. Then I will do the square root, which is 1.2247. So let's print. Is that what we have? Okay. Yes, 1.2247. So basically, when r is using a vector to perform any arithmetic operator, it's going to sort it each of the elements after the other with the operators that you have. So the next one, z minus 1, you find the square root, then 3.19 minus 1, then you find the square root. That's where we have all these values in. So more examples so we can get this perfectly. So let's say we divide z by my square, then assign this new variable to a new variable name my div. So we created another variable name my div, and we want to get z divided by my square. Don't forget that our z is equals to this is the value for our z, 2.57 and 3.19, and the value of my square, which is what we got here, is equals to 1.224745, 2.449490, and this value. So what I will do to get this value is that it's going to take each of these elements, 2.50 divided by this, then 7 divided by this, and 3.19 divided by this, which is what we have here. So let's print this. So that's what our value is going to give us. So let's test that again. 2.50 divided by 1.224745. What do we have? 2.041 exactly. So I treated it one after the other. Concept of recycling r, what do we mean? So when we have two vectors of the same length, r simply performs the specified arithmetic operations element by element, exactly what I explained here. So let's take, for example, we have this vector a that has elements 1 3 5 7, and we have this vector b that has 1 2 4 8. Don't forget that is going to do this element by element. So it did it 1 plus 1, 3 plus 2, 5 plus 7, 5 plus 4, and 7 plus 8, element by element. So but let's assume that, so if the vectors are of different lengths, r recycles the shorter vectors until it is the same length as the longer vector. What do I mean? From our example of vent array, z was a vector of length 3, right, which is 2.57 and 3.19. Then this 2 is a vector, let's say this is just one element, so, and this is another element of 100. So basically r was Z was a vector of length 3, yes, but technically 2 and 100 are each vectors of length 1, which is just 2 and just 100. So R recycles the 2 to make a vectors of 2s and 100 to make vectors of hundreds. So let's say we open another chunk here and we have this vector name recycle. So in this recycle, just to illustrate what this means, we have the Z, which is these elements, and we have this another vector of 2's, 2, 2, 2, and we also have this 100, 100, 100, 100. So R recycles these shorter vectors of 100 and 1, 2 to make it 300, 300s, 1, 2, 3, and 2's, 1, 2, 3, so that what we have the same number of elements as what we have in Z. So um, so in that way, R is going to pick this value 2.50 multiplied by this 2 plus 100. They will pick the next value 7 multiplied by 2 plus 100, and 3.19 multiplied by 2 plus 100. So each of these has the same 3 elements. So this is another function name, which is identical. So like I told us in the beginning of the class, that if you want to know what a particular function, you don't know what it's used for and you want to get more details, so you just use this command question mark, then you type in the function name identical and you click enter. It's going to drop in your help panel. So here is it. So this identical is used to a safe and reliable way to test two objects for being exactly equal. It returns true in this case, then false in every other case. So we want to test if um, these two vectors recycle that we just created here is the same with this vector array. So we use this identical function name, and when we do that, let's print it. So the result is true, which means that they are the same. So can we now print and see if really it's the same thing? Yes, 105 and 114 and 106. So we can see that it's the same. This is just to explain to you that when R is dealing with vectors that have different elements, R is going to recycle the shorter one to have the same number of elements as the longer one, just as what we explained here. So another example, let's say if the length of the shorter vector does not divide evenly into the length of the longer vector, R will still apply the recycle method. It will still apply the recycle method, but it will throw a warning to let you know something is not quite right. Now let's get this. We opened another chunk, and we have a vector A, and this vector A has 4 elements, 1, 2, 3, 4. Then we also have another vector B that has 3 elements, 20, 10, and 100. So from our knowledge of recycle, so if R wants to really do this expression A plus B, R is going to pick this 1, 20, 2, 10, 3, 100. Now when it recycles, this 4 will go for this 20, which is what I explained. This 4 will go to this 20. However, by the time it recycles this B, it does not match up with the elements we have in A. So let's print it so it can get that better. Once we print it, see, we have a error message that says longer object length is not a multiple of the shorter object length. However, we still got our answer. So our ensure it tells us that it still gives us our 1 plus 20 to be 21, 2 plus 10 to be 12, 3 plus 100 to be 103, then 4 plus 20 after it recycles to be 24. So which means that for the second time R is recycling all these values, the elements in A, we've exhausted it. So that means it's going to is going to truncate the other ones. I hope I will get that better. So this is the end of today's class, and this class we've been able to talk about or how to assign values to variable names, how to name a variable in R. We talked about vectors, talked about how to combine vectors, we talked about how to create new vector from existing vectors, and we've also talked about vector arithmetic and the concept of recycling in R. So join us next time as we dive into more interesting topics on R for beginners. Thank you so much for your time. My name is Tumiki Adebayo. Don't forget to subscribe to our channel and turn on your notification bell so you can be notified whenever we post a new video. If you have any question, please drop it in the comment section, and see you next time. Bye.